Forget that. There we go. So let's go to scratch.mit.edu. Click that good old Start Creating button.
Hold on.
And then we'll be there in just a second. So, okay. Let's get started. I just want to show you a bunch of cool things in Scratch. We're nearing the end of our journey with Scratch, to be honest. We've seen pretty much all that it can do. There's just a few extra things that I haven't talked about. So let's do some of those today. I want to first teach you about clones. So you can have sprites in your program, and you don't have to, like, if you want 50 Scratch Cats, you don't have to add 50 Scratch Cats to your program. You can have the Scratch Cat clone himself. So that is kind of cool. So let's make like an outer space-y kind of program. Let's make a field of stars, and it's like warp speed. We're flying through them, and so we'll have 50 stars bouncing around in random spots, random sizes, random directions, stuff like that. Then we'll make them transparent too. So a lot of stuff going on, but the concept is cloning. So let's talk about that. So let's set the scene. Bye-bye, Scratch Cat. We don't need you today.
Why not?
Not for this program, at least. Let's make I think there's a space backdrop. Yeah, galaxy or stars, either one. So let's have a stars backdrop. And then the sprite that I want to clone is, I think there is a star sprite. There we go. There's a star. So here's the sprite. There's the one sprite in my program right now, this star. And of course I can give it a location, and I can point it in some direction, but it's just one guy. It's just one little guy, and I would like to make many of him. All right, many stars, all with their own sizes, directions, locations. All right, so you could just add another star. You could add 50 stars by clicking choose a sprite 50 times, or you can use this cloning stuff. All right, so let's make a program that when the green flag gets clicked, we generate 50 stars. We make 50 star clones. So let's do that. Event when the green flag is clicked. Does anybody see that? The block that has to do with cloning? Somewhere over here. Down here. There it is. It's in control. Create clone of myself. Isn't that kind of cool? So if you run this, you'll create a clone of yourself. And I want to make 50 clones. So I'm going to put this in a loop. So repeat 50 times. Make a clone of myself. Boop. And that's kind of intuitive, right? We're going to make 50 stars total. So let's maybe put a little comment just to remind ourselves. We want 50 star clones total. And so if I run this, it will 50 times create a clone of the star. Whee! It did it. But something funny kind of happened. We made 50 clones of stars, but they're all on top of each other right now. There's 50 of them, I promise. But there's nothing different about them. If you made a clone, if you don't say anything otherwise, they are clones. They're in the same spot. They have the same direction. They have everything exactly equal to one another.
It's not working for mine.
That's what it means to be a clone. So, yeah, did you make sure you have exactly what I have?
Yes, I did. Yes, I am getting what I'm wanting.
There you go. All right, so when you're tired of this, you can click stop and have all the clones disappear. You're back to the original one. But, okay, that's the start of this. What do we want to do? When every clone begins its life, there's an event for that. So when I start as a clone, every clone can run a program, their own little program, if they hook into this event. And that's what we're going to do. So every clone, once it gets birthed, we will have it like go to a random spot. I hope that makes sense. So, all right, random spot. So go to a random spot once the clone begins its life. Let's do that. We want a bunch. We want them to begin in different places. So go to a random position. That'll work. And so now when I click the green flag, it'll make 50 clones, but every clone will start running this program when it begins its life, and they'll all go to different places. So that's pretty cool. That's a good start, right? And of course it's random. You can click stop to go back, and green flag to do it. And it's different every time because it's random. So that's fun. Let's make it cooler, because these stars are all pointing in the same direction right now, right? They're clones of the original one with that 90 direction. So let's have them all have different random sizes and random directions. So when they begin their lives, let's give them a random size. Where's that? Probably in looks. Change size or set size to some percentage. Let's set the size to a random percentage between, I don't know, 25 and 100, or I don't know, maybe we have big stars, 25 and 200. I'm not sure. Something like that. So now when I run this, every star will begin its life in a random spot, and then also it will set its size to a random size. That's kind of cute. Now some tiny stars and some big stars. And then I also want the direction to be random. So I'm going to need a random in a second, so I'll just take that out for a little bit. And then I want to point in some random direction. What are all the different directions we can have? It's 0 through 360, right? So pick a random degree direction, please. 0 through 360. And so now they all won't be like pointing straight up. So every clone runs this program. That's their event once they begin their life. So there we go. And so now they're pointing in different places. You can click stop and try it again. It's all going to be different. Question? That is down in control, which is not in events, surprisingly. It's all the clone stuff is right here at the bottom of orange. That's the event when those stars begin their lives. So that's pretty cute, right? It's not bad. Any questions about this so far? So we make 50 clones, and then every clone does this. It's much better than making 50 star sprites, giving them all the same program. Okay. One other thing for the first bullet, let's have them bounce around. Let's have every star bounce around, and because they all have a random direction now, let's have them move in that direction, just forever until the end of time. This is space after all. So forever, little star clone, forever loop, forever just go in your current direction, move in your current direction by 10 steps, let's say, and then bounce off the edge if you hit one. So 50 clones, all doing this, and then once they pick their direction, set their size, all that fun stuff, they just start moving. So, whee, there they go. Very fast moving stars. It's like warp speed. If you want to go slower, you can change how many steps happen per frame. Like, okay, 2 steps. That's cuter. That's softer. Does that make sense?
I think it does, yes.
There is one little problem here. It's that the original star is just sitting there by itself. You see it? That original star has its own program. Its job was to make 50 clones of itself, and then nothing happens to it after that. So that's no fun. This star is kind of like not moving, like everybody's orbiting around it. I think that this star, after it clones itself, maybe it should just hide because it's not going to move. So after, like, its job is just to clone itself, and then the clones do stuff, but that original star can just hide itself. How about that? So let's do that. In looks, I think, right? Hide yourself. You're done. You're happy. We're happy now. And then every clone should be shown. So make sure that when the green flag is clicked, that original star is shown, so that when it clones itself, all those clones are also shown. But once its job is done, it can hide itself. I feel like that's a good idea. So there it goes, making 50, and then it's going to disappear. Again, showing itself, making 50 copies, disappearing. Bam. Any questions about that? So that's a good start. Two main programs, one for the original star, show itself, make 50 copies, hide itself. And then every clone does all this. Go to a random spot, pick a random size, pick a random direction, and then forever move. 2 steps at a time and bounce off the edge. Good with all that? Making enough sense. The last thing I want to do for this example is, I guess, the stars are smaller. Some stars are smaller. They're supposed to be farther away, right? If you're drawing things and they're smaller. So let's make smaller stars more transparent, like there's haze in the atmosphere, and smaller things farther away are not as easy to see. So that's the ghost effect, if you remember that. That's transparency. We're going to set the ghost effect to a value, depending on the size. Okay? So where's that? That's in, I assume it's in looks. Yeah, set something effect to blank. So before we start moving off forever, set the ghost effect to some number involving our size. All right, and we can access our size. Our size is here. It's a variable somewhere. There it is. It's here in looks. Here's a size variable. Tells us how big we are. Or like size 100 is the default one. But we can set the ghost effect to something depending on our size. So, okay, what's the setup? If our size is large, we want to show ourselves. So if size is equal to 100, we want to make sure the ghost is 0. We want to be completely visible. the ghost should be 0 if it's 100. And then maybe like if the size is 25, let's make the ghost effect something large so that it's kind of hazy. When it's a bigger ghost effect value, it means it's more transparent. So like if the size is 25, maybe the ghost effect can be 75%. See how there's like an inverse relationship there? So if the size is 100, the ghost effect should be 0. If the size is like 25, the ghost effect should be 75. So I think what I want to do is set ghost effect to whatever our current size is minus 100. Or sorry, 100 minus the size, excuse me. 100 minus our size, whatever that is. So that if it's 100, this will cancel out, make the ghost effect 0. If it's only 25, this will make a big ghost effect value. See that? So I'll subtract our size from 100, and I think that's the way to go here. Oops, what have I just done? I just accidentally checked something, sorry. So let's go to operators, get a minus out there, set ghost effect to 100 minus our size, and that'll make it so that if the size is large, the ghost effect is small, and vice versa. So things with smaller sizes have bigger ghost effects. And then look at how we have very transparent stars that are super tiny in the background. And that is our star field. Different every time, of course.
Yay, I did it again.
All right, so yeah, I think that's all I want to do for our first example. It's pretty cute. Any questions about this one? Yes?
How come my starting size was 60?
Oh, that you maybe have changed. You maybe changed the default size of your original star. Did you maybe set it down here? Or maybe you set this, like you accidentally ran this block once. Just hard code this, like stop it. If you hard code the size to 100, hit enter. That should fix it. I believe. I'll help you if it doesn't. Any other questions? Yeah, so let me save this so that we have it later. Have you all done attendance, by the way? I'll stop that in just a second. So do it now if you forgot. So that's saved. Another example. There's another feature of Scratch that makes our life easier for that ghosts program, so I want to remake it. There's a concept of messages in Scratch and other programming languages. And so we have the ability to like talk to other sprites. We can send messages to them. It's like we're shouting to them. That's the metaphor. So like there's a concept of senders of a message and listeners for a message. So here's the idea. Sender and listeners. We made it so that all those ghosts were watching a variable's value when really we could have just sent them a message if we knew how to do that. So the idea is that the Scratch Cat is going to be the one to shout out, like the Scratch Cat's going to be the one to create a message, like the little stamp, address and everything. He's going to shout out, hey ghosts, show yourself. That's going to be how this works. This will be the Scratch Cat doing that. Oops, Scratch Cat. And then all the listeners would be the ghosts. They're going to be listening for, they're going to be listening to the Scratch Cat's message saying, wake up or hide. Show yourself or hide yourself. So that we got our skeleton. That'll be a listener for this message. And then what were the other ones? I think it was a ghost and a bat. You can have as many listeners as you need listening to these same messages. All right, so that's the idea. The Scratch Cat can shout out a message, and a bunch of other sprites can listen for that message and respond to it. Like, oh, you just told me to show myself. I will run the show block. Oh, you just told me to hide myself. I will run the hide block. So let me show that to you. It's pretty nice. Makes it a lot easier to do that other program. So let me blank everything out. We need a Scratch Cat. Give him a name. He can be Scratch Cat today rather than Sprite 1. And then what was the backdrop? It was like woods or something, right? There it was. And then I had a ghost and a skeleton and a bat.
That's gonna be super scary.
Ghost, skeleton, and a bat. Or whatever 3 scary things you care about, or maybe more. So here are my little sprites. They can have, of course, their own individual programs. You can highlight them, give them their own stuff. But all right, what did we have before? It was like when the green flag gets clicked, the Scratch Cat asked us, do you believe in ghosts? And that was in sensing, right? Ask, do you believe in ghosts, and wait. And then, based on the answer, we did one thing or another. Like we tell the ghosts to hide themselves or show themselves. So control, if something, then something. So if the answer was yes, show the ghosts, otherwise hide the ghosts. So let's make a comparison here in operators. So we're going to compare for equality. If the answer was equal to yes, if that was true, then show the ghosts, otherwise hide the ghosts. And so that's kind of the setup we had before. We can reuse most of this, and we're going to use messages instead. Do you see a spot where there's a word? There's wording about messages. It's down here in events. So essentially a message is you're making your own event. When I receive some message, broadcast a message, broadcast and wait. Here's the idea. Broadcasting means shout out your message, and then when I receive is what to do if you're listening for that message. So there's a default message for every program. It's called message 1, but we can make some new messages. All right. So let's make a new message called show ghosts. That's something that can be shouted by somebody. And let's also make another message. I'm just clicking on when I receive message 1, going to new message there. I'll make another one called hide ghosts.
Wait, hold on. Hold on.
So these are messages that I can broadcast now. I can shout them out with a broadcast block, and then people can be listening for them with this when I receive event. Okay? Hopefully that makes a little bit of sense, but like this kind of translates into exactly what we want.
What did you type here? I see ghosts.
I called my messages hide ghosts and show ghosts.
Hide ghosts.
Like I'm shouting out for somebody to do something. Hey ghosts, hide yourself. Hey ghosts, show yourself. Okay? Were we all able to get those new names for our messages?
I got it, yep.
Alright, so this is kind of the setup. The Scratch Cat's going to be like the director, shouting out these lines or these stage commands. So if the answer is yes, hey, shout out, hey ghosts, show yourself. Otherwise, shout out, broadcast, hide yourself, ghosts. And then at the very start of the program, we don't know if the user believes in ghosts or not. So at the very beginning, we should say, ghosts, hide yourself, just to be sure. So technically, you don't need an if else. You could just have a normal if without the else, because they're already hidden at the start. But this is helpful still. Giving us some review, I guess. And so this is a bit cleaner, I think. It's like shout out, and then the ghosts will be listening for these messages, and they'll be running different code based on what's happening. So let's go to the ghosts program, for example, and let me show you how easy this is. So there's 2 messages that I want the ghost to listen to, hide ghosts and show ghosts. So it's going to be listening for somebody to shout those out, to broadcast them. And so what do we want? What should a ghost do when it receives the hide ghosts message? It should hide itself. There's no need for a forever loop or anything to be waiting. It's just like, if you receive this message, hide yourself. If you receive this message, show yourself. That's what it means to do those things, right? That's how you respond to those. And so that's legitimately all you have to do for the ghost, the skeleton, and the bat. It's like, give them these programs. When you receive hide ghost, hide. When you receive show ghost, show. So everybody, the ghost and the skeleton, did one of them not go? They're on top of each other. There we go.
My ghost disappeared.
You can bring it back.
How do I do that?
Well, I believe in you.
I don't know.
Alright, so I got a ghost and a skeleton and a bat, and they're all responding to the same messages in the same way. When they receive show ghosts, show themselves. When they receive hide ghosts, hide themselves. And then it's the Scratch Cat shouting it out. And so if I click the green flag, first thing that happens is we broadcast hide ghosts, and every ghost / skeleton / bat is going to hook into this and understand, okay, I just heard that, I'm going to hide myself. It's another gun. And then if I answer yes, we're going to hit the true branch of this if block, and the ghosts will show themselves. Or if I say no, we're going to hit the else, and they're just going to remain hidden. They're going to see hide ghosts again, and they're just going to keep hiding. Okay. Are there any questions about that? So a message is just something that you can send to people, and anybody is allowed to listen for those messages and do something in response. This is much cleaner, I think, than having these ghosts listen to a variable's value in a forever loop. That was kind of ugly. This is nicer. Any questions about this code? It's very simple code now that we understand the message passing idea. So that's helpful, I believe. Let's see here. Yeah, if we're good with this, do shout out if you're not. But I want to give you this code. I'm going to give you screenshots because I want you to play around. Just like I had you play around with the last one. Oh, good job, passed me. I already copied and pasted. Sweet. So here's this code. Try and recreate this example if you haven't already, and change it up. Change it up a little bit, assuming you followed along. Like make all the ghosts say boo, or have them float around, or have them flicker like we did before. See if you can remember how to do that. Maybe they'll respond to maybe and just like sometimes randomly show themselves or randomly hide themselves. Try to do something cool. Take 5 minutes. We got plenty of time. And you can make a new message to send to the ghosts if maybe gets passed as the answer. Something like that. See what you can do in 5 minutes. Try and compete with the people next to you, and shout out if you have any questions. So take some time to play around.
I'll do that. Okay. Maybe I can do something with the bat this time.
There you go. Did you figure out how to add the ghost back?
Yep, I did it. I just clicked on this. See what I did? I just clicked on
I knew
show
you
ghost.
could do it.
Yep, thank you. Muchas gracias.
There you go. All right. Enjoy. Flickering effect was randomly changing the ghost effect, setting the ghost effect to a random value in a loop. That's how we did it. Couple more minutes, play around. Right. Oh, that was fun. There will be plenty of time to keep playing around if you're having fun. But I have one more cool program to make. It'll take a little while. So let's do that. I did not want to close this. All right. Oh, first of all, did any questions come up as we were playing around? Did it all make sense? All right. Because what I have been working towards is one of the original video games that hopefully everyone's heard of. It's called Pong, right? We're going to make single-player Pong, which, if you've never seen Pong before, that makes me feel old. Not that I was alive when it came out, but at least I know about it. It's just this idea where you have two paddles. It's like ping pong, but virtual. You have two little paddles, but we're just going to make single-player Pong. So there's a paddle and there's a ball, and the ball bounces around, and it's your job to hit it, right? Hit it with the paddle so that it bounces off, and then you just keep playing until it doesn't hit your paddle and you miss it, then you lose. Right? So that's Pong. We're going to make a single-player version of this game, and so we're going to need a paddle and we're going to need a ball. So that's going to be the start of this. But first, let me save this program so that I can give it to you later before I clear this all out. So feel free to set a backdrop to something you're interested in, but I'm going to delete the scratch cat and keep it blank for a second. I'm going to include a ball sprite. That's going to be necessary. And then there's also a paddle sprite somewhere. They made Scratch with this in mind.
Well, do I not need to save the previous one?
Not unless you want it later.
Was it? What did you say again?
If you want it later, you should save it. All right, you can just make it again. And then I'm going to set the paddle to be, why is 180 not, why does that look jagged? That's confusing. And let's change the size of the paddle to be like 150%. Again, it looks jagged. How about 0? Now it's happy. All right, 0 direction for you, paddle. That's a decent size, I think. Should it be any bigger than that? 175? Let's do 150. I don't know. We can play around with that. But here we have a paddle of a certain size. You can give it a different size, as I did. The ball looks to be a nice size to me. And the idea is we want to be able to move the paddle up and down, and we know how to do that already. We could hook into the key press events, like when the up arrow is pressed, move the paddle up, and when the down arrow is pressed, move the paddle down. But I want to show you something cooler than that because that takes time and that's kind of hard. If you're in the middle of a game and you want to move something really fast, let's use the mouse for once. Let's make the paddle follow the mouse. Isn't that cool? That'll be nice. So when the green flag gets clicked for the paddle, it should always be updating its location to be the same as the mouse location. So forever, Mr. Paddle, set your coordinates to be whatever the mouse coordinates are. And so it's going to be, okay, there's a lot of things that I want to do here. So there's something involving the mouse somewhere. I think it's probably in sensing. I can get the X coordinate of my mouse and the Y coordinate of my mouse, which is nice. It's they got to be on the screen, though, for it to actually make sense. But the last one that it was on the screen was this one and this one. And then I can set my sprite's X and Y coordinates to those values. So set your X, set your Y to the same as the mouse's X, the same as the mouse's Y. It's kind of cool. So forever, just do that. If I click the green flag, look what happens. Whee! The paddle is following my mouse. It's setting its X coordinate and its Y coordinate to the same as my mouse's X coordinate, my mouse's Y coordinate. Isn't that fun?
I didn't.
This is not how Pong should be, though. The paddle should not be allowed to move left and right. That's kind of cheating. It should only be allowed to move up and down. So the way we can make sure that only happens is set the paddle somewhere to start, somewhere on a line that we care about, and then never change its X value ever again, because the X moves left and right. Just only change the Y value of the paddle to the mouse's Y. So even if the mouse is way over here, just take the Y value. Don't take the X value too. See how it's just going to move along that line if it's only changing the Y value?
No X. Take away the X value, right?
Yeah, it's just keep the X coordinate, whatever was there already. Whatever we put in there. Negative 175 for me, apparently. And now when we run it, it'll just forever follow the Y coordinate of the mouse, which moves it as we want to move it. Any questions about that? Does that make sense? So we want to keep the same X coordinate, just set it to the Y coordinate of the mouse, even if that's a different X coordinate. So that's nice. That's fun. And now let's make the game happen. All right, there's a lot involved that is not listed here. So second step of this game, right, is the ball needs to move. So let's go to the balls program. The ball just needs to move forever. So when the game starts, when the green flag gets clicked, the ball just needs to start moving around. There are some options here. How do I want to explain them? Well, let's just do it now. Let's just do this. So forever, little ball, please move in your current direction and then bounce off a wall if you need to. And so here's the game so far. This is the balls program, by the way. So forever, move 10 steps in your current direction, if on edge, bounce. So this is the ball moving like this. It's a very boring game because it's just moving left and right because its direction initially was 90. It's facing straight right. It's always going to be on the same line, which is kind of no fun. So I think what we should do is make it random. Let's start the ball in a random spot on the screen with a random direction. Yeah, that'll make it for a more interesting game. So let's see. So when the green flag gets clicked before we start moving the ball, let's make this a different game each time. Let's have the ball go to a random spot, and then let's have it pick a random direction as well. So point in direction, something random. Let's see. So pick random between 0 and 360. And now we've got an interesting game, hopefully. A different game each time. Ball goes to a random spot. The paddle goes to a different random direction. And so we can start playing and like it's different. It's moving in different ways. So that's kind of nice. I think this is too hard of a game right now, though. Because imagine, I guess I'll have to use the board for this. Imagine, like, the paddle starts here. Oops. Imagine the ball, it could go to any random position. To the balls program. Imagine the ball begins its like random position. Like the ball begins its like right here with a direction of left. We'll immediately lose the game. Yeah? So let's fix that. Let's make it so that the ball can only ever start on like the right half of the screen. So where the x coordinates are positive. Does that make sense? Like here's negative x coordinates. Positive x coordinates are the right half of the screen. So let's make sure that happens for the ball. So don't like go to a random position entirely. Let's control that random position.
36. Is that 136 or 106?
This one is 135, I think.
Okay.
But it could be anything. We want it to be random, but positive x. Y can be positive or negative. It could be any top or bottom half. That's fine. So let's set the x and y in a different way. Let's be like go to x, y, and like let's pick from some numbers now. Let's see. How do I want to do this? Yeah, go to x, y, where these are random numbers. So let's make x positive. What's like the biggest, like from 0? The x coordinate can be 0, it can be in the middle, or way over here, which is 232, 240. I don't know how big it can be. Let's be up to 200. Let's say doesn't really matter. And then the y could be anything. Let's make it negative 200 to positive 200. Apparently that's as far up, and I guess it's not as tall. So like I don't know, negative 150 to positive 150. That looks like normal numbers. But the y can be anything, negative or positive, up or down half. But we want it to make sure we're only at the left half when we begin the life of the ball. So let me put a comment here because that's kind of tricky. Come on, I want to move you down so we can read you over here. All right, so pick a random location for the ball, but make sure that it's on the right half. I don't know if I can spell. It's on the right half of the screen. And so a positive x will ensure that it's on the right half of the screen. Y can be whatever.
What did you say again on the note? Pick a random what?
Location.
Random location for the ball. But make sure.
So now,
where is it on? It's on what?
Oh, this comment is just for you, the programmer. You can write whatever you want.
The right half of the screen.
So when the green flag gets clicked, now what are we going to do? We're going to pick a random x that is positive, big or small positive, and then the y can be anywhere. So it's somewhere in this right half is where the ball will be in its life now. And so that was an unfortunate direction for the ball, but eventually, if you play it enough times, it'll eventually get to you. And so it's different every time, and you can't just immediately lose now because the ball won't like teleport to the left of the paddle. All right, so that makes it like a game that we can actually win. Any questions about this code so far? This is the balls program. It just starts, once we set it up, it just starts moving. And then the paddles program is just keep on tracking our mouse. Just move your Y to wherever the mouse's Y is. Okay?
Okay.
So, I guess the next piece of the puzzle is we have to have the ball bounce off the paddle, right? That's how we play this game. And so, how do we know that the ball has hit the paddle? Do you remember that block? Yeah, there's a touching block. We can check, is this current sprite, it's always from the point of view of the current sprite, is the current sprite touching one of the sprites that I have? That'll be how this works. So if it's touching, if the ball is touching the paddle, let's do it here in the forever loop. Just forever, like move 10 steps, bounce if you're on the edge, and then also bounce if you hit the paddle. Like put it at the bottom there. So we're going to add an if, all right? It just needs to be an if, because otherwise just don't do anything if it's not true. If we're not hitting the paddle, just have it do normal stuff. So if, this is from the ball's perspective, so if the ball is touching the paddle, then do something. Then bounce off, right? So now the question is, what does it mean to bounce off? So here's the paddle. And I am purposefully going to do this in a less than ideal way so you can think about a better way. And I will also show that better way to you later in a future lecture. So let's say the ball is coming in towards the paddle. Normally, right, the ball should like bounce off that way. And that is something I want you to think if you can figure out how to do it. But I'm going to make it easy. What does it mean to hit the paddle and bounce off? You change your direction. Okay, so let's just say, to make it easy on ourselves, let's say if the ball ever hits the paddle, just like bounce off in the exact opposite direction. That's an easy calculation. Just do a 180. Just add 180 to your current direction. That'll flip you around and start moving the other way. That's what it means to hit the paddle and bounce off. Yeah? So let's do that. That's a good start. So if we're touching the paddle, then change our direction. Point in direction, whatever our current direction is, plus 180. So like turn 180 degrees is one way to do it. Let's get some practice using variables. Why not? Point in direction, whatever our current direction is, plus 180. Either block would work though. Point in direction, my current direction, plus 180. You could also have just done turn left 180 or turn right 180. But I like this way. And so now if it's ever hitting the paddle, it will change its direction immediately so that it starts moving, like in the next round of this loop, it'll start moving 10 steps the other way. That's what it means to bounce off. And so that's an unfortunate starting direction, but there we go. Ooh, that was fast. Whee! So now, forever, look at the loop. The loop is the important part right here. Move 10 steps, that moves the ball in some direction. If it ever hits a wall, it'll bounce. That's the next thing it checks. And then we have our if we're touching the paddle bounce code. If it's touching the paddle, if that's true, then it shifts its direction by 180 so that in the next round of the loop, when it moves 10 steps, it'll move 10 steps in the opposite direction that it was coming in from. And it won't be touching the paddle anymore, of course. Does that make sense to us? That's how that works. And then, of course, this is fun and all, but we want to be able to lose the game too. That's what it means to be a game, I guess. So there's one last piece of this puzzle. If the ball ever hits the left wall, then it's game over. All right? So we want to make the game stop once we lose. We'll use a stop block for that in a second. But there's a few different ways to discover whether the ball hit the left wall. You can like do some coordinate calculations. That's possible. You can be like, if the x is ever negative 249, then the game's over. An easier way to do that would just to be add a giant sprite that covers the left wall and check if you're touching it. That's the better way. That's the easier way, I would say. So So let's add a new sprite. There's a nicely named sprite called, I think it's just line, that's capable of covering an entire wall if we rotate it, give it a 0 direction.
We have to put a line.
If I put the line over here, I can just make the game over whenever the ball touches the line. That's easier. That's like the out of bounds wall or something. I don't know. That's the easiest way that I can come up with for Pong. So that's how that works. So now let's have the line be in charge, because like this ball's code is getting very complicated. Let's have the line be in charge of checking if the ball touches it, rather than the ball being in charge of checking if it touches the line. So blank line program, let's give it a program. Let's be like, all right, line. When the program is running, forever keep watching the ball and see if it ever touches you. Because if it does, the user has lost. So forever keep checking if the ball is touching me. So this is the lines program, and so it's from the perspective of the line. So if the line is ever touching the ball sprite, then the game is over. Right? And so one way to stop the program is to use the aptly named stop block. And so if this is ever true, the game is over and we should stop the game. So that's in control. Just scroll to the bottom. There's a stop block. And notice how there is nothing that could go, there's no hook edge like a Lego for things to go below it. It must be the end of the program. That'll stop everything. Stop everything that's running currently. And so if the ball is ever touching the paddle, if the ball is ever touching the line, this is the lines program, then stop the program. Stop everybody. And so here it goes. Let me lose the game. Oh no, it was so hard. There, I lost. The second the ball touched it, it stopped everybody. See that? Does that make sense to us? So this is the line, forever watching the ball. If it ever touches it, it stops the program. That's pretty much the game. I forgot about this. There we go. One last thing I want to do. I want to show you how to make your own sprites. So let's make a custom little banner sprite that just says you lose, something silly. And we'll display that when the game is over. So I'm gonna make one more sprite because now we have a real game. Like we can play this, and it works, and we can eventually lose. We should laugh at the user if they ever lose. So let's choose a sprite, but not click the button yet. Let's scroll up to paint because I want to paint a brand new sprite, and I'll make it say you lose or something. You lose, sad face, very large text or something. I don't know. And there's a little text button there. And so that could be your sprite. And you can give it a name. We're right now in the sprite editor. If you want to go back to the code, you just click from the costumes tab to the code tab. And now this is given a default name of sprite 1. We can call it game over sprite or something. I don't know. And obviously we don't want this to be displayed while the game is running and the game is not lost yet. So let's make that happen. When the green flag is clicked for this sprite, hide yourself. Hide yourself, and then let's see here. How do I want to do that? I do want to have it hide itself at the beginning. But if the game is ever over, I want to show it. How do I check if the game is ever over? Well, it's the line that notices when the game is over. It kind of has to pass information to the you lose sprite. That sounds like our ghost program. Let's use a message. Let's make a game over message. So where's all that? That's in events. So instead of message 1, can I rename this? No, apparently not. So instead of message 1, I'll make a new message called game over. Some message that can be broadcast. And it's the line that notices when the game is over, and so it can broadcast that. Broadcast message 1, broadcast. Oh, did it not save? Sorry. New message. Game over. There we go. Broadcast game over. And now this sprite will be watching for that. It'll be listening. When it receives the game over message, now it's its time to shine. It will show itself.
Wait, I can't see that. Where is broadcast over again?
when the game is over. So if the ball ever touches the line, that means the game's over, so we should broadcast the game over message.
And what do we do for you lose again?
That's this sprite, and so it starts out its life hidden because the game isn't over once the game starts. But if it ever receives that game over message, if the line ever says, "Oh, we're done," then it should show itself and display the "you lose" sign. All right, so let's watch this working. It's kind of cool. Let me lose the game. Oops. Whee, there I lost. But as long as the game is not lost, it will not show itself because it starts off its life hidden. But if I ever lose, bam, it broadcasts game over before stopping everything. And this code is able to hook in that split second before the game is over, and it shows itself. It responds to the message. Okay? This is definitely a complicated example, but you understand everything. You know every little piece. You can study this. I believe in you. Are there any questions about that? Definitely a fun one. Maybe if you're interested, you could try to make it 2-player, something cool like that. But yeah, if we are happy, I will save this. Did I not already say? Yeah. So let me save this so you can have it and study it. And I believe that's all I want to talk about as far as the lecture goes for the day.
Okay.
So let me release your next programming assignment. It's going to be, I believe, something similar to this today. I want you to make, not Pong, that's too easy. I want you to make Space Invaders. That's another old game that's classic. I want you to make that in Scratch. All right. So this very nice man has made a tutorial for Space Invaders in Scratch. I just want you to watch the video and follow it. And you can make it as fancy as you would like. So exactly, yeah. That would work. That would work. Let me mute myself just in case this is like copyrighted or something. But here's the video. You're gonna watch it. It's super nice. This person understands. He's talking to people who are just learning to program. And if I'm connected to the internet, it will eventually load.
I understand how you feel and how the internet works sometimes.
Let's see if I refresh the page, if that does anything. Wow. Well then. I promise there's a video that would play, and I just want to show you how it works in just a second. There it goes. It's refreshing itself right now. There it goes. So there's just a bunch of things. There's going to be events involved, all this messages stuff that we've been talking about. But like, here's the left side. It's going to be the aliens are like taco sprites for his program. You can make it as cool. You can use whatever sprites you want as your enemies. But that's what it's going to look like. You have a little shooter at the bottom, and then you can shoot out little bullets, and they hit these little taco sprites as enemies. But you can change it up all you want. But that's going to be how that works. So just watch that and make it work. Yeah. Oh yeah, I think so. That should be possible. Let's see. If you go to, there's upload button up here. So not choose a sprite, not paint, but upload. See that? I think you can just upload an image at that point. Yeah, good question. So you can make your own enemy, upload it. So that's your project if you've never programmed before. That's your next assignment. So as usual, upload a video to show me your code, show me it running, show me you understand it slightly. This will be due week 6. All right, so the 14th apparently is going to be when I'm having this due. Any questions about this one? So just follow the video, make it as fancy as you want, but at a minimum, do what the video tells you to do. If you are a programmer, if you've taken a computer science class before, then you're going to do this. Instead, you're going to read these chapters of that book and do exercises 9 and 11. Make a video as usual. Show me that you did it. And again, let me know if you'd like to do something custom for yourself. Maybe you want to make your own game in a fancier programming language. So, yeah. Any questions about that one? So if you've programmed before, please do that. Okay, so I think I have given you everything that I want to give you. The rest of the time is yours to get started if you'd like.